All right, so now I want to start looking at some examples where we're integrating a power of sine times a power of cosine. And so I've got some general advice here first. When you're evaluating integrals of the form, so some power of sine of x or sine of 5x or whatever it is, times some power of cosine of x dx, then the first approach to consider is to look for an odd exponent. If both powers are odd, then you could focus in on either function. But so just focus in on a function with an odd exponent. Break one power away. So that's what generally what we should do. So you break one power away, push it to the end of the integral. That's where you're going to form your differential du, which means u will be the other function. So say we split off, we've got a cosine cubed, we split off a cosine x to the first. That's what we're going to call du, cosine x, which means, so we work backwards, okay, well then u must equal sine of x. And so that's what's different with the problems in this section. So the technique of integration that we apply is not actually new. It's u substitution. So it's something you covered in Cal 1. But what's different here with these trig integrals is we tend to focus on the differential first. So on the du, we look for what's the derivative of one of these trig functions. Push that to the back, call that the differential du, which means we're trying to write whatever's left in terms of u, which may be sine of x, maybe cosine of x. That's the overall idea. Some trig identities that you should memorize if you don't already have memorized that will come in handy in this section. Well, so there's like the Pythagorean identity, but all the other Pythagorean identities stem from this one. But sine squared plus cosine squared equals 1. You might remember that from your trigonometry days. Well, so another version of that equation could be written as cosine squared equals 1 minus sine squared, or if we want to isolate sine squared, it's equal to 1 minus cosine squared. These equations are going to be really useful because then when we're trying to write, so we break off our du, we're trying to write the rest of the integral in, let's say, in terms of sine. We can use these identities to convert. If I have some expression of cosine left over, I can convert it to sine using this identity. Any even power of cosine will be able to apply this identity, but I am getting a little ahead of myself, so let me get to the actual examples that I gave you. So with this first example, this one's meant as kind of a warm-up. These are both raised to an odd power, but notice how we've got this cosine x dx, oops, and this should be dx, sorry guys. We've got this cosine x dx already on the end here. If we call this du, cosine x, then that would mean that u is equal to sine of x. And so, yeah, this example might be a little overly simplistic here. So then the sine cubed would become u cubed. The cosine x dx becomes du. And our antiderivative is just power rule, u to the fourth over 4. So that's sine of x to the fourth over 4. And there's your answer. Like I said, this is a warm-up problem, maybe a little too wimpy there. What if we've got the integral of, and I want to match the one I put in your notes, so cosine to the 5th times sine to the 4th. And this example will let me say more about why we focus on the odd exponent in particular. But for now, let's just listen to that advice. So if we focus in on the expression with the odd exponent, that's this cosine to the 5th. So break away one power is what I'm suggesting here. So what I'm saying with that is take this cosine to the 5th, write it as cosine to the 4th. So I'm going to borrow one power. I'm going to push it to the back here. Cosine x dx. Sine to the 4th here. So if this is what I'm going to call the differential du, cosine x, then thinking backwards, okay, that means that u is going to equal sine of x, like we had previously, which means I need to write whatever's left here completely in terms of sine of x. So This part here, sine to the fourth, I mean, that's straightforward. That's just u to the fourth. Cosine to the fourth, though, and I've got another unfortunately placed glare here from the window. Sorry about that. We want to write this in terms of sine because we're trying to use that substitution to solve it. This is going to be u to the fourth. This is going to be du. What are we going to do about this if u equals sine of x? So what you can do about it is use this trig identity. So notice that if it's cosine to the fourth, that's cosine squared squared. And so that's 1 minus sine squared squared, which just because of space, I hope this is okay with you guys, that's 1 minus sine squared. So I'm going to go ahead and write that as u squared squared. So the integral of cosine to the fourth x dx, I'm going to try to block the glare for you guys. So integral of cosine to the fourth x times sine of x to the fourth times cosine. So if we do this substitution, u equals sine x, this becomes u to the fourth. This cosine to the fourth becomes 1 minus sine squared squared, so 1 minus u squared squared here, times du. Okay, and I'm going to stop writing at the very bottom of the board. Let me come back up here. So that means, so in order to integrate this, we should distribute this u to the fourth. Whoopsie, order of operations. Hang on. Let's write this. Forgot about that squared. We've got 1 minus u squared squared times u to the fourth. We need to evaluate the exponent first because of order of operations. So 1 minus u squared squared is 1 minus u squared times itself. Oops, 1 minus u squared. If you multiply that out, that's 1 minus u squared minus u squared. So minus 2u squared, and then negative u squared times negative u squared, so that's positive u to the fourth du. Now just power rule for antiderivatives. Well, antiderivative of 1 is u, minus 2 antiderivative of u squared is u cubed over 3, plus antiderivative of u to the fourth is u to the fifth over 5. And then we're almost done. We just have to write the final answer in terms of x, remembering that u was the stand-in for sine of x. So this is sine of x minus 2 times sine cubed over 3 plus sine to the fifth over 5 plus c. There's your final answer. This should be a capital C.